Hello, this is Kuntal Chakraborty, Assistant Professor of Electrical Engineering Department, Greater Kolkata College of Engineering and Management, GIS Group. I am just going to give a lecture on an important topic, that is 8255A PPI. So its PPI means Programmable Peripheral Interface. Basically 8255A is as an interface. It can be used to connect different input-output devices with the microprocessors through 8255A. And this 8255A is basically programmable. The input-output ports that can be programmed, that can be used as input-output as well as bidirectional way, and we can operate in different modes also, and that can be programmed so that it can be used as simple input-output mode, it can be used as handshaking modes. So this is basically used for the interfacing. This 8255A basically used almost in every with the every processors. So now 8255A, I will discuss the structure of 8255A. So before that, I will actually giving the introduction of 8255A. That is, 8255A is a general purpose programmable input-output device designed to transfer the data from input-output to interrupt input-output under certain conditions as required. So as I already discussed, it can be used within almost any microprocessor, and it consists of 8-bit bidirectional input-output ports. That it has a 24 numbers of input-output ports, means it has a 3 ports basically, each of 8-bit or each has 8 lines. So means we have 24 input-output lines, which can be configured as per requirement. I already discussed this one is programmable, so that's why as our requirement we can configure it. So 8255A has 3 ports, as I already discussed, that is port A, port B and port C. Port A consists one 8-bit output latch buffer and one 8-bit input buffer. Similarly, port B is similar like port A. Actually, it contains one 8-bit output latch buffer and one 8-bit input buffer. Port C basically split into 2 parts. One is the upper part and another one is the lower part. And here we will see the constructions. So here we are seeing that we have port A, port B, and port C is basically divided into 2 parts. Port C upper and port C lower. Port C upper and port C lower. So here actually 2 groups is formed. One is a group port A and port C upper. These 2 ports are basically formed group A control, and port C lower and port B form group B control. So here each port has port A has the pin PA0 to P7 that can be used as input output. Port C and port C lower and port C upper, these can also be used as input output. Port C upper means PC4 to PC7, and PC0 to PC3 that is used as a port C lower. And we have a group B. That is one important part is port B, and it PB0 to PB7 pins we have for this port B. So this can be used as input output also. So these all the ports that can be used as input as well as output. So now here basically in this read-write control signal, we are seeing that read and write signals, control signals are actually here to read and write data from any device or into a device. And here we have a reset signal by which the 8255A that can be reset. And here we have a chip select line by which 8255A that can be activated. And we have a data line D0 to D7 by which the data that can be transferred to microprocessor, and from microprocessor that can be transferred to the input output devices. And we have a data bus buffer, and where the intermediate data that can be stored here. So that is the overall block diagram that we are seeing, and these A0 and A1 lines are used to select the port A, port B, port C as well as the control register. So this 8255A basically I already told that this device is programmable. So every port that can be used as input output, as well as that can be used bidirectional way, handshaking way. So that this can be done by using a control word into a control register. So 8255A has a control register in which we have to write a control word, that is a data bit pattern. So after writing the data bit pattern in particular specific data bit pattern, we have to write into the control register, so that the ports that can be selected in as we want, and as well as we can select different modes of the ports also. And that's why A0 and A1 is used to select different ports as well as control register. Now how it is actually selected, so we are seeing here in this picture. So A0 and A1, basically 8255A has an internal decoder, and A0 and A1 basically give us 4 combinations of data, that is 00, 01, 10 and 11. So by selecting 00 in A0 and A1, we can select the port. By 01 we can select port B. By giving the 10 signals to A0 and A1, A1 and A0, then we can select the port C. And similarly, if we write 11, then we can select the control register. So this is a very important one. So before any operations, we have to write the control word into the control register, so that we can configure the ports as we want. So next is the addressings of 8255A. So 8255A can be addressed in two way. One can be addressed by memory mapped IO technique and can be addressed as IO mapped IO technique. First we will try to understand the memory mapped IO technique. Is basically this is an input output device that is connected with the 8085. So if you want to connect it, then we can connect by using 8 address lines. But if you want to connect in memory mapped IO technique, then we can use 16 address lines here. So here we are seeing that A0 and A1 are used to select the different ports and control register, and A2 to A15 is used to select the 8255A. So here A15 is 1 and all are 0, and if you provide all are 0 and A15 as 1, so then the CS bar means active low signal that will be sent to CS bar, so that the 8255A that can be activated. So now here we are seeing that the address of different ports and control register, that A15 that will be equal to 1, and all the bits from A2 to A14 that will be 0, and the combinations we have 00, 01, 10 and 11. So these other basically provide some address. So basically we will get 8000 for port A address, 8001 for port B address, 8002 for port C address, 8003 for control register. So this is the design that I made, but any kind of design it may be. So at the time the chip selection, it may be the change, the pattern of the chip selection that will be changed as we and usually the word. As usual, the word, the address lines that will be also changed. So that is a memory mapped IO technique, and here we are seeing the similar way we are actually we try to address 8255A using IO mapped IO technique. So here we are using A0 to A7 lines. Here A8 to A15s are not used. So this is the input output mapped IO technique, or peripheral mapped IO technique. So here A0 and A1 are used to select the different ports. So now here we are seeing that A2 to A7 we will give it as 1 and all are 0, so that the chip select bar that will be 0 means active low signal that will be sent here, so that the 8255 that can be selected. So now we will provide A7 as 1 and all A2 to A6 are 0, and we have 4 combinations, that is 00, 01, 10 and 11. So that will basically generate 80, 81, 82 and 83H. So 80H means the address of port A, 81 is the port B address, 82 is the port C address, and 83 is a control register address. So that is the way we can address 8255A, and this is the design that I made, but design that can be changed. So these are the two techniques, memory mapped IO and IO mapped IO technique, by which we can address 8255A. So next I will try to find out the modes of 8255A. I already told that 8255A has a control word, a specific control word, and by writing this control word into the control register, we can configure the ports, as well as we can perform the different tasks by using different modes also. So the modes is very important for 8255A. Basically, D7 bit of this particular control word actually select the mode. So here, if it is 0, then it will be the BSR mode, that is bit set reset mode, and if it is 1, then that will be the input output mode. And input output mode, basically 3 types of input output mode we have in case of 8255A, that is a mode 0, mode 1 and mode 2. In case of mode 0, that is a simple input output ports, so it means A, B and C, 3 ports can be used as simple input as well as output. Now mode 1, handshaking mode, that is basically handshaking input output mode, and here the port A and port B, that can be used as an input output port, and port C is basically used for the handshaking purpose. And for mode 2, that can be used as a bidirectional data bus, means here the port A, that can be used as a bidirectional mode, bidirectional way, and the port B either can be used as mode 0 or mode 1. And here the port C is used for the handshaking purpose. So these are the 3 input output modes and BSR modes. Next we will try to understand the control word of 8255A. Now I already discussed D7 bit. Basically this will actually select the input output as well as BSR mode. If it is 1, then that will be equal to input output mode, and if it is 0, then that will be equal to BSR mode. So now D0 basically give us the status of the port C, whether it is used as input or output. If D0 is 1, then that can be used as input, and if it is 0, then this port C lower, that can be used as output. So this is used for the port C lower. So if we write 1 here, then that can be used as input. If we write 0 here, then that can be used as output. So next is a D1. This is for the specified bit for port B. And if we write 1 here, then port B, that can be used as input, and if we write 0 here, then that can be used as output. Next is a D2, that will actually select the port B mode. So port B, that can be used as input, 0 mode and mode 0 or mode 1. So if we write 0 here, that port B, that can be used as mode 0, and if we write 1 here, then that can be used at mode 1. So this is basically the group B. I already discussed in the block diagram that group B is basically consists of port C lower and port B. So this is a group B, and these 3 bits are used for the group group B, and port selections as well as input output port selections as well as the mode selections of group B. Next is a D3. That is used for the port C upper, and if we write 1 here, then that can port C upper, that can be used as input. If we write 0 here, then that can be used as output. And similarly for D4, that is used for the port A. If we write 1 here, then that can be used as input, and if we write 0 here, then that can be used as output. So now D5 and D6, these 2 bits basically used to select the mode of port A. If it is 0, 0, then that will select the mode 0. If it is 0, 1, then that will be equal to mode 1. If it is 1 don't care, then it will select the mode 2. So that is the way the port A modes that can be selected by using D5 and D6. And here we have D7. I already discussed that 1, actually if we write 1 here, then that can be used as input, and if we write 0 here, then that can be used as output. Next we will discuss the different modes of 8255A. As we already discussed, input output modes are 3 types, that is mode 0, mode 1 and mode 2. So first we will try to understand the mode 0. So basically here the mode 0 is a simple input output mode, and we will take an example so that this mode can be understood very easily. So here basically port B and port C lower are used as input port, and port C upper and port A used as output port. So DIP switches are connected with the port C lower and port B, and LEDs are connected with the port A and port C. Now here A15 is used to provide the chip select here. So here we are using the memory mapped IO technique because 15 address lines are used. Here A0 and A1 is used to select the port A, port B, port C as well as control register. And we have two control signals, read bar and write bar. These are the active low signals, and MEMR bar and MEMW bar is actually provided by the microprocessor for the read and write operations. So as it is a memory memory mapped IO techniques, that's why we have to provide MEMR and MEMW bar signal to it. So here we have a reset out signal that is connected with the 8085 microprocessor. This is basically provide a reset out signal to the 8255A to reset the 8255A. So now here we have a problem that we have to solve by using this mode 0. So here the DIP switches that is placed in port B, the corresponding bits of port A that is connected LEDs that will blink. At the same time, if we press a switch of port C lower, at that the LEDs of the corresponding LEDs of the port C upper that will blink. So that is the problem that we have to solve by using the mode 0 technique. So now first we will try to create the control word. Here the D0 actually provide us the status of the port C lower. So now it is used as input because the DIP switches are connected here. So that's why we have to write 1 here. And D1 that will provide the status of the port B, whether it is used as input or output. So here the port B is used as input because the DIP switches are connected. So that's why that will be equal to 1. And D2 basically provide the mode selection of port B. So here the mode is mode 0. That's why that will be equal to 0. And here the D3 bit actually provide the status of the port C upper, and here it is used as the output, so that's why that will be equal to 0. And D4 that will provide the status of the port A, whether it is used as input or output. So here the LEDs are connected with the port A, so that's why that will be equal to 0. So now D5 and D6 that will the mode selection bit of port A. So here the mode is 0, so that's why that will be equal to 0 0. So the port A mode is mode 0. Now here the 1 is basically specify the input output mode, and mode 0 is input output mode, so that's why D7 bit that will be equal to 1. So that is a control word, and it hexadecimal, if you convert it into hexadecimal, then it will be number, then it will be equal to 83H. And if we write 83H into the control register, then the port that will be configured as we want or as in the figure. Now what will be the address for the selection of port A, port B, port C as well as control register? So here we have to provide 1 so that the chip that can be selected. So here the combinations we have 0001, 1011, so that port A, port B, port C and control register that can be selected. So from A2 to A15s are missing, so that will be the don't care. So let the don't care be as 0. So now 8000 by the address 8000 that will select the port A, 8001 that will select the port B, 8002 that will select the port C, and 8003 that will actually select the control register. So first we have to write 83 into the control register, then we can perform these operations. So here 83 is written into the accumulator by using MVI. So the 83 that will be stored into the accumulator. Now we have to send the 83H to the control register. The address of the control register is 8003. So now the STA 8003, it means the content of A that will be sent to the 8003H. So the control word that is written into the control register. So as per the diagram, the ports are configured as well as the modes are also configured. Now we will try to find out the data from the port B whether any key is pressed or not. So switch is pressed is not. So that's why we have to use the LDA. The address of the port B is 8001. So the content of the 8001 means the data that will be stored into the accumulator, and we have to send this data to the port A. The port A address is 8000. So we will use STA, by which the data received from port B that can be sent to port A. So STA 8000 means the content of A that will be sent to the port A. Now we will try to find out the data from port C lower by using LDA 8002, that is the address of port C, and the data that will be stored into the accumulator, and by which we can understood that any DIP switches is pressed or not. And what we have to do is that the lower byte data that we have to send to the upper byte, lower nibble of data that we have to send the upper nibble. So that's why we will try to match the upper nibble here by using AND operations, by using 0FH. So the lower nibble that will remain the same, but the upper nibble that will be equal to 0, and the lower nibble data that we have to shift into the upper nibble side. So that's why 4-bit shifts is needed in the right hand side. So we will use left hand side. So that's why we have to use 4 RLC by using the 4-bit that can be shifted into the left hand side. So the lower nibble that will be shifted into the upper nibble. So after that shifting, we will send the data that is received from the port C lower, that will be sent to the port C upper by using STA 8002, means the content of A after shifting the data that is stored into the accumulator, that will be sent to the port C. So that is the way by which we can perform these operations. So here in this mode 0, we actually port A, port B and port C are used as simple input output mode. Here we don't have any handshaking signal, means there is no understanding between the input output devices with the 8255A. But in case of mode 1, that is used as a handshaking mode, and that can be used as input handshaking mode as well as output with handshake. So first we will try to understand the mode 1, that is input with a handshake. So in this operation, we will see that the port A and port B, here these 2 ports are used as input, and some bits of the port C are used for the handshaking purpose. So now here what is happening here, when a data that will send from a peripheral device to the 8255A, at the time it will send a STB signal, that is the strobe signal that will send to the 8255A by telling that I already sent a data. So after receiving the data, 8255A will send an acknowledgement signal, that is the input buffer full. By receiving the signal, it will send an acknowledgement signal to the peripheral device by telling that I already received the data. And after these operations, these 3 bits that will be active, and at the time the INTR A that will generate, and it will send to the 8085 microprocessor, and it will interrupt the 8085 microprocessor, and the data that is received from port A that will be sent to the microprocessor after successful interrupt occurred. So that is the way the port data from port A that can be sent to the 8085 microprocessor through or any microprocessor through 8255A from a peripheral device. The same thing that can be done by using port B also. Now here in this section we are seeing that 6 and 7 pins of port C are not used, so that can be used as input as well as output. So here the read signal is very important because this is used as an input one, so we have to read the data from the port. So that's why read signal we have to provide to the 8255A, so that the data that can be read from the peripheral devices. So now we will try to write the control word here. So here D0 is the selection of port C lower, whether it is used as input or output. So here the port C lower bits are used for the handshaking signal. So here that will be the don't care. And D1 is used as a port B, and it is used as input, that's why that will be equal to 1. And D2, that is the mode selection of port B, so here this is a mode 1, so that's why that will be equal to 1. And here D3, that the port C upper, and here 6 and 7 number pins are left to use as input as well as output, so we can use it as 1 or 0. And D4, that is used for the port of A, that port can be used as input as well as output. Here the port is used as input, so port A is used as input, so that's why we have to write 1 here. So here the mode of the port A, that will be actually mode 1, so that will be equal to 0 1. D6 and D5 will be 0 1 for the mode selection of port A. Now here the 1 is used for the D7 because this is the input output mode, so we have to write 1 here. So that is a mode 1, that is the input with handshakes. Next is a mode 1 output with handshake. So what is happening here, the port A and port B is used as the output, and here what we are seeing that when a data that will send from 8085 microprocessor or any microprocessor to 8255A, and we want to send the data to the peripheral device, so at that time we will send the OVF signal to the peripheral device by telling that 8255A is already sent the data. So after receiving the data by the peripheral device, it will send an acknowledgement signal to the 8255A by telling that it already received the data. So after the activation of all three signals, INTA and OVF A bar and ACK bar, INTR that will be generated, and this INTR signal that will send to the microprocessor by telling that our data that is sent by the microprocessor already sent next data that can be sent from 8085 microprocessor to 8255A. So the same operations that can be made by using port B also. Here the port 4 and 5 pins of port C are not used for the handshaking purpose. So that's why that can be used as well, input as well as output. So here the write signal is very important. Write signal, active low signal that we have to provide for the write operations to the peripheral device. So that is the control signal that we have to provide here. Now we will try to find out the control word of this particular mode. Here the D0 is used as a handshaking purpose, so that's why that will be equal to don't care. And D1 is used as a output bit, means the port B is used as output port, so that's why that will be equal to 0. And D2, that is the mode selection of port B, here the mode is 1, so that will be equal to 1. And D3, here the upper bit, upper port of C, that is used as input or output. Here the 4 and 5 pins are used input, either input or output, so that's why it may be 1 or it may be 0. And D4, that is used as a port A, that is used as output, so that's why that will be equal to 0. And D6 and D5, that will select the mode of group A, so that is a mode 1, so that will be equal to 0 1. And 1 we will write it to the D7 section because this is the input output modes. So next we'll discuss the mode 2 of mode 0 input. So it may be mode 2 mode 0, it may be mode 2 mode 1. So I'm just going to discuss the mode 2 mode 0 input. So in this mode 2, the port A that can be used as bidirectional way, and port B that can be used as mode 0, as well as mode 1 means that can be used as handshaking signal, handshaking mode also. So here we are seeing that mode 2 mode 0 input signals. So here we are getting that the port A that can be used as bidirectional way, and here the STB, IBF signals, OBF, SCK signals are used here for the handshaking purpose. I already discussed in mode 1. So here as port A is used as a bidirectional way, so that's why output handshaking signal as well as input handshaking signals we need here. So every time the port data that is in or out through this port A, so INTR that will be activated and that will send to the microprocessor by telling that that operation data received or sent by the 8255A. And if it is mode 2 mode 1, then the port B that is also used as a handshaking mode. And for this mode 2 mode 0 input, here actually the control word is the D0. Say here the D0, that the port C lower, here the port C lower port bit 0 to 2 is not used here, are not used here. So that's why that can be used as that can be written as 1 or 0. So that can be used as input as well as output. Now D1 that is used for the port B port that can be used as input. So that's why that would be equal to 1. And D2 that will select the port of port B. So that's why here the port B mode is mode 0. So that's why that will be equal to 0. And here the D3 that will select the port C upper, whether it is used as input or output. So port C upper, all the bits are used for the handshaking purpose. So that's why that will be equal to don't care. And D4 bits that can be used as input as well as output. So here it is used as a bidirectional way. So that's why that would be equal to don't care. So as it is used as a bidirectional way. And the mode of the port A that is mode 2 means that will be 1 don't care in case of in D6 and D5. So by selecting 1 don't care, we will select the port A mode as mode 2. Now D7 that will be equal to 1 as it is the input output mode. So here the read and write operations both that can be performed as it is bidirectional mode. So that's why we have to use the write as well as read signal, these control signals that we have to provide for read and write data to a device and from a device. And next mode is a BSR mode, that is a bit set reset mode. This is not an input output mode. So here basically the port C is used as a bit set reset mode. Port A and port B are not used. So here the control word that will be changed for the BSR mode. So here the D0 bit is used for the set and reset of the particular bit of port C. So the bit selection that can be done by using D1, D2 and D3. So here the combinations we have, 8 combinations we have, 0, 0, 0 to 1, 1, 1, that will actually select the bit 0 to bit 7 of port C. So by selecting a bit, we can set a particular bit as well as we can reset a particular bit. Here D4, D5 and D6 are not used here. And as I already discussed, if we write 0 in the D7 bit, so then that will be used as a BSR mode. So this is the control word for the BSR mode that we can write in this way. So I already discussed the structure of 8255A, and we already give some examples for how the mode 0, mode 1 and mode 2 are used, and every time we write the control word for different modes and the BSR mode. So thank you.